Alright guys, hoping all is well with everyone. In this video series, what I'm going to be starting to show you guys is word and story problems that you can definitely see in algebra and on standardized tests. And what I want to help you guys do is get comfortable with being able to take a verbal mathematical sentence and formulate it into a mathematical equation. And the way that we're going to do that is I'm going to start to show you keywords and buzzwords that help you equivalent the verbal sentence into a mathematical equation. But what I first want to talk to you about before we jump into this question is remember George Polya's four-step approach. And this works for story problems and word problems really well. What we're going to be doing is taking this four-step approach and being able to solve for a variable and as well as check our answer. So the first step is to understand the problem. Now, that doesn't just mean to read the problem. What it means is to be able to understand what quantity or value or variable you're solving for. This allows you to define a variable in the first step. The second step is to devise a plan. Now, this is probably the trickiest and most difficult step out of the four steps, because what you're trying to do is formulate an equation that you can use to solve for your variable given the circumstances in your question. But however, once you have that equation set up, you can execute the plan, which means carrying out your equation. Then the last step is one of the most beneficial steps looking back. This allows you to make sure that your answer that you've come up with makes logical and practical sense. Does your answer make sense upon the circumstances of the equation given to you? So, that being said, let's look into our first story and word problem and approach it with the four-step approach. So, story problem 1 says, find three consecutive integers such that the sum of the first and twice the second is 86 minus 3 times the third. Now let's do our first step here. We're going to define a variable, but before we do that, I want to show you some key and buzzwords that will definitely help us in formulating an equation. Find three consecutive, sorry about that. Find three consecutive integers such that the sum of the first and twice the second is 86 minus 3 times the third. Now, you're probably asking yourself, how did he know to underline all of those words? Well, when you take a verbal mathematical statement, what you're trying to do is you're trying to take ideas from it that you can formulate an equation from. So when it says to find three consecutive integers, basically what I'm going to be doing is finding three values that are directly next to each other. So when you think of consecutive integers, think of, for example, 1, 2, and 3. 1, 2, and 3 are consecutive integers. They are whole numbers that follow directly after each other. Now, what I want you to take from that, in an algebraic sense, we have x as integer 1, but to get to integer 2 being consecutive, we're going to add 1. So the expression x plus 1 is our second integer. Likewise, with our third integer, it's going to be x plus 2. So what I want to introduce to you here is that our variable is just the first integer. Okay? So this is define a variable. And in this case we have, because x is just going to be our first integer. But notice how our second and third integers are directly related somehow to our first. Now, continuing on with the sentence, it says such that the sum, that means addition, of the first and twice the second, first integer and second integer, is 86 minus 3 times the third. Now there's one very important buzzword I did not underline, for the reason that it is extremely important. and that is. When you see is, think equals. So now I'm going to take this information and put it into a mathematical expression. And as I'm formulating the equation, I'm going to show you where I'm getting the equation parts from. 3 consecutive integers such that, and again I got the 3 consecutive integers set up as such, the sum, so I'm going to be adding, the first, we've stated that our first integer is just x, and being plus, twice, 2 times, the second, our second integer, twice the second, 2 times the second integer, is equals 86 minus 3 times, 3 as your coefficient, the third. And we've established that the third integer is x plus 2. Now just to recap here, remember these consecutive integers are such equal to, this x is the first integer. To get to the next integer, it's still the first integer but 1 more. And then the third integer is the first integer but 2 more. Okay? So now that I've formulated this equation, this is the second step. I formulated an equation. Now I can go on to step 3 and execute it. Now, basically what this is, when you look at it, it's a double-sided variable equation, which means that there's a variable on both sides, but because it's the same variable, we're just solving for it. So let's go ahead and work this through. So we have x plus, we're going to be using the distributive property here, so 2 times both x and 1, that's how the distributive property works. We're going to be taking a value outside the parentheses and multiplying it into each of the individual terms in that expression. So we have 2x plus 2 times 1 is 2 is equal to 86 minus, again, same idea, taking the distributive property, 3x, but be careful here. This is a minus 3. So, minus 3 times positive x is minus 3x. Minus 3 times a positive 2 is a minus 6. So when you're distributing a value on the outside of a parentheses, you're not only distributing the value, but you're also distributing the sign. So one thing that can come in handy is to put a positive sign anytime a term doesn't have a sign on it. Okay? Now let's go ahead and kind of put our like terms together. Remember, like terms have the same variables, and those variables are to the same powers. Constants are also like terms. So we have x plus 2x. That's a like term. So we have 3x plus 2 is equal to 86 minus 6 is a like term. So 86 minus 6 is 80 minus 3x. Okay. Now we can take this 3x is positive, so we're going to add 3x to both sides to get the variable on one side of our equation. So now we have 6x plus 2 equals 80. And then, I'll continue up here. 6x plus 2 equals 80. Subtract 2 from both sides, and we get 6x equals 78. Divide by 6, and x is equal to 13. Okay? Now, remember what our x is representative of. X is equal to our first integer. So our 3 consecutive integers are going to be 13, 14, and 15. Now, here's how we're going to check this. What we're going to do is we're going to take our first, second, and third integers consecutively, and we're going to plug them in for this equation. Okay, so I'm going to go ahead and erase this. And this is part of our fourth step. So we're going to look back and make sure that this equation works. But instead of having x plus 1, and x plus 2 as the consecutive integers algebraically, now we have values that we can sub in for. So we have 13, our first integer, plus 2 times the second integer, which is 14, is equal to 86 minus 3 times 15. Okay, so now let's go ahead and do the arithmetic sums and differences on each side. So let's go ahead and do the multiplication first. So we have 13 plus 2 times 14 is 28 is equal to 86 minus 3 times 15 is 45. So now we just have to see if these two values are identical. 13 plus 28 is 41. 86 minus 45 is also 41. So this is how we can definitely check to make sure our answer works. When we plug in the variables and the consecutive integers to their corresponding algebraic symbols, being the x plus 1, and x plus 2 for the 3 consecutive integers, and they equal in terms of the equation is balanced on both sides, then we have done the question correctly. Okay, but this is the consecutive integers story problem. If you guys have any special requests for a similar problem like this, I'd be more than happy to do so, and I hope this helps you guys out. But again, if you have any questions or concerns, never hesitate to contact or message me, okay? I hope this helps you guys out, and enjoy the rest of your day. Thank you for watching.